want to say a little bit more about the solar-terrestrial interactions here. Last time we talked a little bit about how the coronal mass ejections and so forth can affect cosmic rays. We also talked about how solar heating, greenhouse effects, just solar radiation affects the Earth, and human interactions are changing that the interaction between the sun and the Earth. What we're doing to the planet is changing that. Now, there are other sort of things here that are involved. Humans have changed it one way. There is some research saying we might can change it the other way, and so some of the research, is involved, of course, for example, trying to use energy in ways that do not produce greenhouse gases. But another area of research is actually changing what's known as the albedo of the Earth. The albedo is how reflective the Earth is. And so if you change the albedo, you can reflect some of this energy back into space. So one strategy is, for example, seeding the upper atmosphere with something that would reflect some of the solar energy back into space, thus cooling the Earth. That'd be a very expensive task, but it is something they're looking at. Another strategy, for example, to combat global warming is in human buildings, where humans have actually built things, is simply change the color of the roof. Dark colors absorb energy, whereas light colors reflect it. In certain hot parts of the country, hot parts of the world, for example, everybody has white roofs to reflect the heat back into space, and that keeps the ground warmer. So one strategy is, all these dark roofs that people like to put on houses, make them white or silver, and that would reflect heat back into space. That would, first of all, make cooling the buildings easier in the summer, less energy used, but it would also mean less energy absorbed, which would cool the planet. Another strategy is possibly to put something in space between the Earth and the sun. Just a big cloud of dust or something in between would scatter some of the solar heating and affect Earth. So these are all sort of what we are looking at as strategies for that. But there's other things that the sun does to us besides global warming. So back to the sunspots and this cosmic rays. We know that more solar activity means that there's fewer cosmic rays. This is what we call the four-bush decrease. We decrease cosmic rays when we increase solar activity. Okay, so all of the coronal mass ejections interfere with cosmic rays coming to Earth. Okay, so it's pretty clear the sun's been dropping in activity for quite a long time here. For like 4 decades, the sun's been slowly dropping in activity. Or maybe you can go back there, to 1960 even. So we might say for almost 60 years, the sun's been dropping in activity. Now, how does that affect humans? Okay, well, balloon flights measuring radiation level in the stratosphere show that over the last number of years that they've been doing this, there's been an increase in radiation levels. They've also been flying flights. This is a real simple experiment that was done by some high school and college kids, volunteering to do this, and out of California back before the pandemic. But they simply, it was a real simple experiment. Each one of them would just check luggage on a flight that had radiation sensors. They also launched high altitude balloons into the stratosphere with radiation sensors, and they just measured over a number of years what's been going on. And we've noticed that over this period of time, there's been an over 20% increase. Now, the data here in this graph ended a couple years ago, but it has continued up like that. So there's been about a 20% increase in radiation levels. at high altitudes. Okay. How does that impact frequent flyers? Well, frequent flyers also get radiation exposure. A friend of mine, a bunch of years ago, a flight attendant, got a letter that she was supposed to sign and return from her airline. And she'd asked me to explain it to her because she said, well, you know a lot about this radiation stuff. And I looked at it and kind of looked up a couple of things and realized that flight attendants basically, and pilots and frequent flyers get as much, actually, and more radiation typically annually than is legally permitted for nuclear waste handlers to get. Now, it doesn't get a whole lot of press attention here, because, it's natural occurring radiation, not man-made. But it is something that is some consequence. Likewise, flight attendants and pilots have a higher incidence of miscarriages and of cancer than the general population. Kind of expected with radiation exposure. Whenever I mention this in class, someone says, well, can you shield the aircraft? And the answer is, well, yeah, you could, but then they'd be so heavy they would not get off the ground. You'd have to tow it somewhere. Okay, so then it wouldn't be an airplane. You just call that a bus. And so, and then you wouldn't need to shield it because it's low in the atmosphere, and you wouldn't have to, the atmosphere would protect you anyway from the radiation. Okay. In Finland, they actually measure neutrons raining down on us from above, and they've been doing this since the early 60s. And currently, we are right near a space age high. So the highest amount of cosmic rays that have been hitting Earth, since the dawn of the space age. And this is about the time they started really seriously measuring radiation falling from space. Again, 2015, this was actually an experiment that was done there in California, high altitude balloons and aircraft, and finding, for example, radiation levels. The peak radiation level is actually pretty high up here. The peak radiation level is going to be in the neighborhood of about between 50 and 90,000 feet. That's a little bit higher than most commercial airliners. In fact, it's higher than all commercial airliners. Commercial airliners are down in here somewhere, but this is still a much higher level than you get at low levels. So, if you take a low-level flight, like a commuter plane or something, it's normally flying pretty low in the sky here, and so you get only slightly more radiation than you would at ground level. Top of a skyscraper gets only slightly more radiation than you do at ground level. But once you start getting at these very high altitudes that most commercial jets fly, then you start getting these higher radiation levels. Well, that's not the end of the story. It turns out that all of these solar wind particles streaming out from the sun eventually meet up with particles moving through space. The interstellar medium is moving. And the interstellar medium gets deflected when it reaches the edge of the Earth's, or the sun's magnetic field. So we have what we call the sun's magnetosphere. And we call that the heliosphere. That's the region of space where the sun dominates. Outside of the heliosphere is interstellar space. And so these particles go streaming outwards, and they eventually start slowing down as they get out here and bunching up, getting thicker and thicker. We call that the solar wind termination shock. So if you were in a spacecraft leaving the solar system, when you got out to that point, you would notice an increase in radiation exposure just to all the buildup of all these solar wind particles. Ultimately, then once you reach the edge of the sun's magnetic influence, that's called the heliopause. So between the termination shock and the heliopause is a region here of actually, interestingly enough, high voltage. Because what happens is the particles from deep space are being deflected around. So this is what's called the bow shock. up here as all these particles are going around here, and they're bunching up right here. So that's actually a different voltage than here. And what's happening is it's causing particles that are out in that area to go shooting inwards, accelerating inwards. So you end up with three different kinds of radiation from space. You have cosmic rays from deep space. These are high energy cosmic rays. You have solar radiation coming out from the sun, and then you have mid energy radiation coming from this area near the edge of the solar system. And so these are all particles that are moving around out there. So the wind particles coming in, bow shock, the solar realm in here, the heliosphere where the sun dominates, that's inside the heliopause, which is really the edge of the sun's influence. Okay, there's actually some spacecraft leaving the solar system. The Pioneers, which were some of the first things launched to the outer solar system, Pioneer 10 and 11, Voyager 1 and 2, and then New Horizons. So 5 spacecraft are leaving the solar system. 3 of them are still working, Voyager 1, Voyager 2, and New Horizons. The Voyagers are the farthest ones that are out, and they have recently, actually, a few years ago, they crossed the termination shock, some decade ago. Then they have recently crossed the heliopause. And so at that point, they are kind of into interstellar space. Not unaltered interstellar space, because they're still in this region of space where stuff's being deflected around, basically the bow shock. Okay, once they get past the bow shock, they'll be in true interstellar space, and they're just now reaching that point. These things were launched in the 1970s, mid-1970s, and they are just now reaching the edge of interstellar space, so unaltered interstellar space. So they're about to move past the bow shock into just the interstellar medium flow. Now, unfortunately, they're almost at the end of their life. They're barely functioning right here. They function by using radioactive decay from plutonium, something called a radiothermal generator, or radioisotope thermal generator. And so the plutonium, as it decays, releases heat. It uses to make electricity, but it's almost out of plutonium. I mean, it's short enough half-life. There's not a lot left, and so it's not producing much electricity. They're barely operating, and the facilities on Earth to receive them are actually facing budget cuts to shut down. And so just as they're reaching interstellar space. But they are still functioning at least a little bit, and we do go listen to them once in a while and get data back that they're collecting from the near interstellar space.